Hello everyone. Now I've just noticed I've got nothing on trigonometry so far, so let's put that straight right away, okay? Because trigonometry is one of my most favourite topics, okay, of P3. I like differentiation, integration, trigonometry, graph sketching. Those are the best ones, okay? And I can't believe I've still not done any videos yet on trigonometry, so I need to get cracking on this one. This is my first one. Might not be the first you're watching, but this is the first one I'm recording, okay? Because I love this so much, okay? I'm going to do one of these questions, r cos x plus alpha, r sin x plus alpha, but related to, as you guessed it, tidal heights. Yes. So what I'm going to do is I'm going to take you through an examination question modelled with tidal heights, and I'm going to show you what that looks like and just why trigonometry is used with tidal heights. Are you ready? Let's go. So here is the examination question, okay? If I just take a step back, you can take a screenshot of that if you want, and then just work your way through it. What I'm going to do is I'm going to take it bit by bit, stage by stage, and show you how it's actually done. So you've got the first two bits, which are the maths bit, the pure maths bit, essentially, in terms of can you actually do this for the 6 marks in an examination question. And then you've got the modelling bits. So this person, Tom, models the height of seawater on this. Okay, so this is the have you got the basic stuff, and then this is can you actually model it. Hopefully you'll go through it yourself, okay, and check your working and your solutions with mine, or otherwise you're just going to roll with it and you're just going to watch the video. Maybe you can't wait to see what's going to happen and you just don't want to hit that pause button. Right, here we go. So part A, express 2 sine theta minus 1.5 cos theta in the form r sine theta minus alpha, okay, where r is greater than 0 and alpha is between 0 and pi over 2. Just note this bit here, when it says alpha is between 0 and pi over 2, set your calculator to radians mode. I feel like Captain Kirk, phases to stun, calculators to rad mode, okay? Because if it's not in radians mode, you're going to get your answers wrong, okay? So that's the first thing you want to do, just check how you're supposed to be working through this question. Degrees or radians, it's in radians, okay? This question's already pretty rad, I'm enjoying it, okay? You probably can tell this is one of my favourite questions, all right? So what we've got to do, well, bear in mind it's one of these questions, you might want to just recall the identity, okay, write it down. So the identity for r sine theta minus alpha comes from the identity from sine A minus B, okay, and the identity for sine A minus B is sine A cos B subtract cos A sine B, all right? So the sine theta minus alpha is going to be sine theta cos alpha minus cos theta sine alpha, all of course multiplied by r. So that's the first thing you want to write down. And what we need to do is we need to match this expression here with that expression there. So all of this is going to be the same as all of that. That's what it means. So when it says write this in that form, it means you can write this like that, and you're just going to match those up, okay? In match those up, you want to pair together the two equivalent expressions. So this bit has got 2 sine theta in it, and you can see this bit has got the r sine theta cos alpha term. So the sine theta there must match with the sine theta there, which means that r cos alpha must be 2, and this bit here, I'll just underline it differently, must match with this here because they've both got cosine theta in it. So cosine theta there, cosine theta there. So the 1.5 must be r sine alpha. Notice you've got negative, that is negative that. So your next line of working will be that. Okay, as I said, r cos alpha is 2, r sine alpha equals 1.5. You may not even see that in the mark scheme, but that's essential working as far as you're concerned to get the values of r and alpha. Okay, now, bit of Pythagoras theorem is needed to work out the value of r, so you can just do r squared is equal to 2 squared plus 1.5 squared. Let's just take a moment to think about why that actually is, because if you recall the identity, sine squared theta plus cos squared theta is equal to 1. So if you square that and add them together, you'll get r squared multiplied by cos squared alpha plus sine squared alpha, if you take r squared as a factor, alpha and factorize it. And that would be just the same as r squared, which is 2 squared plus 1.5 squared. So you can work out what that is, and r turns out to be 2.5. 4 plus 2.5 2.25 is 6.25, square root of that is 2.5. Then to work out what alpha is, just do that one divided by that one. Do it that way round, because we use the identity tan alpha is sine alpha over cos alpha. So tan alpha, sine alpha over cos alpha. So that means that tan alpha is 1.5 over 2. The r's cancel, of course. Inverse tan of 1.5 over 2. Just remember, radians, no, the sound didn't go funny then, I just sort of said it really, really quietly. Okay, radians, so 0.6435. So that's the first bit. Okay, right, it's going well so far, isn't it? I feel it is anyway. Just remind us of that answer there, because we're going to need it for part B. Find the maximum value of this expression here, 2 sine theta minus 1.5, because just check that they are the same, because sometimes they change slightly. Okay, this one's not, it's identical to that. So when it says find the maximum value of this, it really means the maximum value of that. Okay. Now just consider what a sine graph looks like. So here's a very small sketch of the sine graph. I apologise, there's a bigger one coming up in a minute. School bell, of course, yes, because I record these in school. So the maximum on a sine graph is there, which is normally 1, the lowest is -1. If we then multiply that by 2.5, our maximum value is 2.5. Okay, so the maximum value is 2.5. Remember the r there just stretches the graph, okay? Larger or smaller, okay? It's a stretch in the y direction, the positive y direction of 2.5 for that, and negative 2.5 for this. The maximum value occurs, the maximum value occurs there when the angle is, pi over 2. Okay, that's really important, because you've got 0, and then you've got pi over 2, pi, 3 pi over 2, 2 pi. Okay, you need to know where the maximum and minimum is. Okay, so the angle when it's pi over 2 gives you a maximum value on the sine graph. That means this bit here in the brackets, because that's the angle, has got to be pi over 2. And that's how you solve the theta. Then you just set the bit in brackets is equal to pi over 2. Right? So if you then just add this to pi over 2, you will get your value. And it does say, it doesn't say how to round it, I just chose to round it to 2 decimal places. Okay? Here's a larger graph of what it actually looks like here. So I actually used Desmos to get the graph of this. So y equals 2.5 sine theta minus. So you can see that the maximum is 2.5, the minimum negative 2.5, and you see the graph has been translated. It's been translated by 0.6435 radians to the right. So you can see this kind of shows you roughly where that is, and that looks to be about 2.21, doesn't it? Okay, it's just visually what it looks like. I hope that's going well for you. If you didn't understand any of this, I'm sure at some point I've recorded another video basically explaining how to do this in a lot more detail. Let's get on to the next bit, because this is the real fun bit. Okay, Tom, I love the name Tom. Tom Baker, Tom Cruise, whichever Tom takes your fancy. Okay, Tom Baker does it for me. Doctor Who, of course. Yeah, the definitive article, you might say. Okay, the Doctor. Many doctors, but Tom, the Doctor, maybe. Yeah, or Tom Cruise, what hasn't he done? James Bond is the only thing he's not done. Okay, or Indiana Jones, or Han Solo. Yeah, okay, yeah, there's lots he hasn't done. Okay, but Tom Cruise has done a lot, hasn't he? Tom models the height of seawater, h meters, on a particular day by the equation. Where has he got that from? Does not matter. It's an examination question. Okay. What you need to do though is see how that relates to the original equation given to you. Okay, if I just show you, the original equation was 2 sine theta minus 1.5 cosine theta. This is 2 sine theta, but written as that instead, minus 1.5 cosine theta. So it's essentially the same. It's exactly the same as before. It's just you've got a 6 plus at the beginning of it. So the first step I'm going to suggest is you rewrite h as this from what we had before. So the 6 and then plus, and we wrote that bit in this form, r sine theta minus alpha. So 2.5 sine, just remember that that value there is what we had as theta from before. Okay, so that's the first thing I'm going to do. because I've not even read what we're supposed to do with it yet. Okay, but that's going to be needed. T is hours after midday. All right, so we'll just hang on to that thought. Calculate the maximum value of H predicted by this model and the value of T when this maximum occurs. That's exactly the same as before. Okay, hence my startled stun. Okay, although not startled because I've seen this many, many times before. It's exactly the same as before. Look, we did the maximum value of this and the value of theta for which this maximum occurs. Right? Exactly the same question. Yeah, hooray, bonus. 3 marks for doing exactly the same thing. Wow, really cool. Okay, so we can do what we did before. The maximum value of this bit is 2.5 as before. When you add on 6, it's now going to be 8.5. Okay, remember, in terms of the graph, adding on 6 will just translate the whole graph upwards 6 units. So it's 6 plus the maximum value 2.5, so it's 8.5. And as with before, this maximum value occurs when this bit is equal to pi over 2. Okay, so we're just going to solve when that bit is pi over 2, exactly the same as before, except rather than theta minus that is pi over 2, you've now got 4 pi t over 25. Quite simple though, because it's A level after all, shouldn't be difficult for you, so just add on that to pi over 2, multiply by 25, divide by 4 pi, and you get your value of t. Calculate value of t to 2 decimal places. There we go, 4.41. Okay, that's it. Ready for the next bit? Oh, sorry, I almost forgot this bit. Okay, that's what it looks like in terms of a graph. Okay, so I also put this graph as well. Notice it looks exactly the same. Okay, except we've just got 4 pi t over 25 instead of theta, and the whole graph's been shifted upwards. There's your model for the tidal height. Okay, so here, imagine it's the tidal sea. Okay, the height of the sea is going to vary between this value here and this value here. So the maximum value of 8.5 and the min value, that would be, well, 6 subtract 2.5, which is 3.5. Okay, so the tides will vary between those two times. Right? Yeah, almost forgot I did that. I just really like to get to the last part, you see. So calculate to the nearest minute the times when the height is predicted to be 7 metres. 6 marks for that. Well, the first thing you want to do is just write down that. Okay, so the height h, which is this, is equal to 7. So equal to 7, go ahead and solve it. Okay, that's all you're doing. Okay. In solving it, you want to subtract 6 to get 1, and then divide by 2.5 to get 0.4, and then get sine of this is equal to 0.4. Inverse sine of 0.4, work out that is, you'll get 2 possible answers. Well, actually you get more answers, okay, but in an infinite domain you get more answers, but you only need the first couple that you can find. So immediately you'll get 0.4115. We did inverse sine of 0.4. Subtract that from pi radians. This is a quick reminder. Where can I stick this? Sorry, that's going to have to go there. So the sine graph, just as a reminder, that's when you're doing the inverse sine of a value. That's your first value, an acute answer between 0 and pi over 2. And then your second answer there, closer to pi. So because of the symmetry, this gap is the same as that gap. So whatever that is, 0.4115, subtract from pi to get whatever that is, 2.730. Okay. Are we done yet? Not quite, because we've got to work out what t is now. So when you add 0.6435 to that and to that, multiply by 25, divide by 4 pi, you'll get your 2 values of t, 2.1, 6.7. Some students stop there, but you shouldn't, because it says find the times. Just have a look at that. This question said calculate the value of t, and then this question says find the times. 2 different things. Okay, so value of t is that to 1 decimal place. The times are how many hours after midday. Okay, because remember it did actually say t hours after midday. Sorry, someone wants to come in and I'm telling them no. Okay, I'm doing this video, I'm with you guys. Okay, you can wait. Okay. So you just got to convert that into hours after midday, which is going to be 14:06, given it's 24-hour clock time, 2:06 p.m. or 18:43, 6:43 p.m. Okay. Lastly, in terms of the graph, what does that look like? Here it is yet again. The only thing I've done is I've just put in this line here. Hopefully you can see it. just about, I hope. Okay, so that is the height of 7, and you're after when is the sea height going to be? 7, exactly. So between those two times of 2:06 p.m, 6:43 p.m, then the height is above that. And you see, it's very, very useful for when you're in the shipping industry, okay? Because ships cannot sail when the tide height is too low, because they'll just hit the ground, of course, and that's not a good thing. Okay, so they need to know when is it safe to be able to sail in the sea. So knowing, for example, if the tide has got to be such that it's at least 7 meters is extremely useful. It means that the ship is free to sail along that channel of water between these two times. If they miss that time, if they're delayed for some reason, or if they're too early, then they can't do it because it's too dangerous. Okay. I hope you enjoyed that question as much as I did. And yes, there will be more to follow. Okay. Thanks for watching, and I'll see you again.